Hello and welcome to my walkthrough of the Pearson Edexcel June 2023 Mathematics Paper 2 Higher Tier Calculator paper. Let's get straight into it. So, question number 1. Work out the value of 25 minus the square root of 43.87 over 6 plus 2.1 squared. Write down all the figures on your calculator display. So the first thing I'm going to put in my calculator is the square root of 43.87. And I get 6.62. So I'm going to leave that on my calculator screen, but I'm just going to write this for you here so you can see what I'm doing. 6 plus 2.1 squared. So all I've done there is square root of 43.87. So that is still on my calculator screen. I'm then going to do 25 minus that answer. And so that gets me to 18.3765, etc. And then on the bottom, we've got 6 plus 2.1 squared. Then I'm going to do divided by and open brackets, 6 plus 2.1 squared, close brackets, and that gets me 1.7652793. And the question wants us to write down all of the figures on the calculator display. Part B. Work out the value of the reciprocal of 0.625. So that will just be a reciprocal is just 1 over the number we have. So 1 over 0.625, again I will do on my calculator, is just 8 over 5, but we'll put it in terms of decimals as the question was asked in decimals, and we get 1.6. Question 2. Write 60 as a product of its prime factors. So we're going to have 60 here. 2 times 30 equals 60, 2 is prime, so we can't go any further there. 2 times 15 equals 30, 2 is prime, so we can't go any further there. And 3 times 5 makes 15, 3 and 5 are both prime, so our answer is 2 times 2 times 3 times 5. Question 3. There are 48 counters in a bag. There are only red counters and blue counters in the bag. The number of red counters compared to the number of blue counters is 1:2 ratio. Helen has to work out how many red counters are in the bag. She says, there are 24 red counters in the bag because 1 is half of 2 and 24 is half of 48. Is Helen correct? You must give a reason for your answer. So our answer is no, because 1 to 2 implies a split of 1 out of 3 of 48 and 2 out of 3 of 48, as when you do a ratio to work out the fraction that the ratios make up, you add up the two numbers in the ratio, the 1 and the 2, and you put them on the bottom, the denominator. So we have 1 over 3 compared to 2 over 3. So we will have 16 red counters and 32 blue. Question 4. Minus 2 is less than or equal to n, which is less than 5. N is an integer. Write down the value of the greatest possible value of n. Now, since n is an integer and it is less than 5, not equal to 5, it will be the highest integer less than 5, which is just 4. On the number line below, show the inequality minus 4 is less than or equal to m, which is less than 1. So we'll go to minus 4, it's less than or equal to, so we're going to colour in the square, or the circle rather. And then we're going to go to 1, and it's less than 1, so we're not going to colour it in, and we're going to draw a line between the two. Part C. Solve 2 over 5g minus 4 is less than 6. All we're going to do here is add 4 to both sides, and that will give us 2 over 5g is less than 10. Then we're going to times both sides by 5 to give us 2g is less than 50. Then we're going to divide both sides by 2. And we're going to get g is less than 25. That's our answer. Question number 5. Here is a triangle and a rectangle. All measurements are in centimetres. The area of the triangle is 10 centimetres squared greater than the area of the rectangle. Work out the value of x. So, it's a right-angled triangle. Right-angled triangle. Therefore, the area of triangle is going to be the width times the height divided by 2, which is going to be 8 times 6x divided by 2, which is just going to be 24x. And we know that the area of the triangle is 10 centimeters greater than the area of the rectangle. So we know that 24x equals area of rectangle plus 10. And the area of the rectangle is just the 5 multiplied by the 4x minus 1 plus 10. That's just going to be 20x minus 5 once you factorize out, minus 10. Just going to move down. So now we want to just work out x on its own. So we'll bring the x's all onto one side. So we're going to say 4x equals minus 10 plus 5 is 5. So x is just equals to 5 over 4, which is the same as 1.25. Question number 6. Last year, a family recycled 800 kilograms of household waste. 57% of this waste was paper and glass. The weight of paper recycled compared to the weight of glass recycled is a ratio of 12 to 7. Calculate the weight of glass that the family recycled. So, similarly to the earlier question, we know this is going to be 12 out of 19 and 7 out of 19 because it's turning the ratios into fractions. So, we know 800 kilograms times 57% is paper and glass. So if I do on my calculator 0.57 multiplied by 800, we get 456 kilograms paper and glass. Now, we know that 12 out of 19 is paper and 7 out of 19 is glass, and we want the glass, so 7 out of 19 multiplied by 456 is the weight of the glass. So 456 times 7 divided by 19 on my calculator is 168 kilograms. And we move on to question 7. A number d is rounded to one decimal place. The result is 12.7. Complete the error interval for d. So d is going to be less than 12.75. Let's move this over here, because we have a less than sign, not a less than or equal to sign. And if it was 12.75, it would be rounded up to 12.8 anyway. And then it's going to be rounded up from 12.65 in a similar way. It has to be greater than or equal to 12.65 so that it does round up to the 12.7. Question 8. Tamsin buys a house with a value of £150,000. The value of Tamsin's house increases by 4% each year. Rachel buys a house with a value of £160,000. The value of Rachel's house increases by 1.5% each year. At the end of 2 years, whose house has the greater value? You must show how you get your answer. So Tamsin has £150,000 times by 1 plus 4% for 1 year, and then we will do the same again for the 2 years. And for Rachel, it's going to be £160,000 times 1 plus 1.5%, again twice. So for Tamsin, this is just going to be 150,000 times 1.04 squared. For Rachel, this is going to be 160,000 times 1.015 squared. And if I do this on my calculator, 150,000 times 1.04 squared is 162,240. And 160,000 times 1.015 squared is 164,836. Therefore, Rachel's house has a greater value. Question number 9. The cumulative frequency table gives information about the ages of 80 people working for a company. On the grid opposite, draw a cumulative frequency graph for this information. So what we have to do here is, for each line, so 20 to 30, we've got 20 frequencies. So at 30, we are going to draw across just here. We have 20 to 40, we have 48 cumulative frequency. So at 40, we're going to do 48, so each square is 1, just there. All we're basically saying is that all numbers that go up to 30, there's 20 of them. All numbers that go up to 40, there's 48 of them. All numbers that go up to 50 is 64 of them. So at 50, we need to draw a cross at 64. At 60, we need 75, and at 70, we need 80. So 60 is going to be 75, and at 70, we need 80. And then starting from 0 on our diagram, we want to draw... Oh, that's a very wiggly line. We need to draw a graph just like that. Part B. Use your graph to find an estimate for the median age. So the median age is just going to be, we know we have 80 in the cumulative frequency. So if we take 40 as the middle point of 80, and our estimate is going to be about here on the graph, and we'll follow that down. An estimate anyway, and we have it as 38 on our graph with my not so straight line. There is a little bit of wiggle room on the mark scheme for this between 36 and 38. So question 10. A biased dice is thrown 60 times. The table shows information about the number that the dice lands on each time. Gethin throws the dice twice. Work out an estimate for the probability that the dice will land on 6 both times. So, land on 6 once is going to be 15 out of the total of these, which is 24, 33, 41, 48, 60, which is a quarter. Therefore, land twice is just going to be a quarter times a quarter, which is 1 over 16. Sally is going to throw the same dice n times and record the number it lands on each time. She will use her results to work out a more reliable estimate for the probability in part A. What can you say about the value of n? So, if she wants it to be more reliable, she needs to throw it more times than the 60 we had before. So, for more reliable, n must be greater than 60. And that's all we need to write. Question number 11. Use algebra to solve the simultaneous equations 2x plus 6y equals 5, 3x minus 4y equals minus 12. So what we're going to do is we're going to get x on its own. So we're going to say 2x plus 6y equals 5 means 2x equals 5 minus 6y, which means x equals 5 minus 6y over 2. Then we're going to put x into the second equation, and we're going to say 3 lots of 5 minus 6y over 2 minus 4y equals minus 12. So times everything by 3, we're going to have 15 minus 18y over 2 minus 4y equals minus 12. We're going to times everything by 2 to get rid of the 2 on the bottom. So we're going to say 15 minus 18y minus 8y, that's 4 times 2, equals minus 24. Then we're going to put all the y's on one side and all the numbers on one side. So we're going to say this is the same as 15 plus 24, so 39 equals 8y plus 18y, so 26y. Just scroll down a bit. So we can say that y equals 39 over 26, which is the same as 3 over 2, or 1.5, and then we're going to put that 1.5 back into the first equation. So we're going to say 2x plus 6 lots of 1.5 equals 5, 2x plus 9 equals 5, 2x equals 5 minus 9, which is minus 4, so x equals minus 2, and y equals 1.5. And we'll move on. Question 12. The points A, B, C, and D lie on a circle, centre O. ABCD is a rectangle. AB equals 8 centimeters, BC equals 10. Work out the circumference of the circle. Give your answer correct to 3 significant figures. So, for the circumference of a circle, that is going to be pi multiplied by d, so we're going to write that first. Circumference equals pi d, where d is the diameter. And in order to work out the diameter, we need the length of AC through point O or BD through point O. So we're going to just do it through here. So we need that length there, and look what we've made, a right-angled triangle, where this is 8 centimeters and this is 10 centimeters. So we can say that d squared, as it is the hypotenuse, is going to be equal to 10 squared plus 8 squared, which is 164. Therefore, d is going to be the square root of 164, which is going to be, on my calculator, 12.80624, etc. And therefore, the circumference is going to be pi times 12.80624. So on my calculator again, we get 40.232, and the question wants the answer 3 significant figures, which means our answer is just going to be 40.2. Question 13. ABC is a triangle. Calculate the size of angle BAC. Give your answer correct to 1 decimal place. So what we can do here is use trigonometry. So let's label the angles. So this angle here is BCA. We'll call this angle X. And this one here is BAC. We'll call this angle Y. We know that sine of X divided by the angle opposite, the side length opposite it, will be equivalent to sine of 70 divided by the side length opposite it. So using this information, we're going to multiply up by 18. So 18 sine x equals 15 sine 70. Therefore, sine x is going to be 15 over 18 sine 70. Therefore, x is going to be sine to the minus 1 of 15 over 18 sine 70. So what I'm going to do is, on my calculator, I'm going to do 15 divided by 18, which is 5/6, multiplied by sine 70. And then I'm going to do, well, which I'll just write it all out here, sine to the minus 1. And in here, we're going to have 0.783077. And we're going to do sine to the minus 1 of that. So we get x equals 51.5 degrees, but we don't want x, we want y. So we're going to say, therefore, y equals 180 minus 51.5 minus the size of the other angle, which is 70. Therefore, our answer is, on my calculator, 58.5 degrees. Question number 14. Show that x squared minus x minus 6 over 2x squared minus 5x minus 3 can be written in the form of ax plus b over cx plus d, where a, b, c, and d are integers. So first we're going to say x squared minus x minus 6, and we're going to factorize this. So we'll factorize it into x plus a multiplied by x plus b, where ab equals minus 6 and a plus b equals minus 1. Now, two numbers that multiply together to be minus 6 could be 1 and minus 6, or 6 and minus 1, but they do not add together in any way to get to minus 1. So we have to use 3 and 2, where it's going to be minus 3 and positive 2, so that it comes to minus 1. So we're going to say here x minus 3 and x plus 2. And then the bottom, the denominator, we're going to say 2x squared minus 5x minus 3. Now, in a similar way, except the fact that we're going to have to do this as 2x plus c, x plus d, as we know that 2x squared is the first term in our quadratic equation. So what we're going to need here is two numbers that say CD equals -3, but also 2D plus C equals -5, as we're going to have 2x multiplied by d and c multiplied by x to get all of the x terms together. So two numbers that multiply together to get -3 is going to have to be 1 and -3, or 3 and -1. So if we say, let's c equal 1 and d equal -3, and then we'll put that in the bottom equation, we get -6 plus 1 equals -5, so this must be correct. Therefore, we have 2x plus 1 and x -3. Therefore, if we write it back out again, equals x -3, x plus 2, 2x plus 1, x -3, x -3 cancels out, and we get x plus 2 over 2x plus 1, which is the format that the question is asking for. Question 15. Here are the first four terms of a quadratic sequence. Find an expression in terms of n for the nth term of the sequence. So, as we know it's a quadratic sequence, we know this is going to be in the form of an squared plus bn plus c. So, for the first term, we know that n will be 1, first term. So, if we substitute 1 into this equation, we're going to say a squared, we're going to say a plus b plus c equals 3. If we take n equals 2, we're going to need to say that 4a plus 2b plus c equals 9. And then for the third term, we will say n equals 3. We're going to have 9a plus 3b plus c equals 17. So what we're going to do now is, if we do this equation minus this equation, we have 9a plus 3b plus c minus a plus b plus c is the same as 17 minus 3, which is 14. Therefore, we can say that 8a plus 2b, as c now disappears, equals 14. Similarly, if we do this equation subtract this equation, we're going to have, I'll write it over here, 9a plus 3b plus c minus 4a plus 2b plus c equals 17 minus 9, which equals 8. So we're going to say 5a plus b equals 8. Therefore, b equals 8 minus 5a. If we now put that back into this equation over here, we can say 8a plus 2 lots of 8 minus 5a equals 14. Expand it out, and we get 8a plus 16 minus 10a equals 14. We'll take 16 off of both sides, and we are left with minus 2a equals minus 2. Therefore, a equals 1. Now that we know a equals 1, we'll put that back into this equation. So b would then equal 3. And now we know a is 1 and b is 3. We can put it back into this very first equation here. And we can say 1 plus 3 is 4. Therefore, c is minus 1 to get us back to 3. So our answer for the term is going to be n squared plus 3n minus 1. Question 16. The histogram gives information about the number of hours some students used their phones last week. The histogram is incomplete. 28 students used their phones for between 30 and 40 hours. 24 students used their phone for between 40 and 60 hours. Use this information to complete the histogram. So we basically, if it's 28 students and that goes up to here, that's going to be 28 just there, which means each square is going to be 5, just like that. So each individual square is going to be 1. So the trick here is that they've told us this is actually over 20 hours, not 10 hours. So we're not looking for 24 up here. We are looking for half of 24. We are looking for 12, which is going to be just here. And we're going to draw this all the way along. You'd use a ruler for this in the actual exam, but I'm on an iPad, so I do not have a ruler. And there we go, and I'm going to write 24 in there. Part B. No student used their phone for more than 60 hours. Work out the total number of students. So, we know that 28 used their phone for 30 to 40 hours, plus the 24. We also know that this bit between 20 and 30 here that's going to be 30 there, that's 35, it's going to be 36. And in a similar way to what we just did for between 40 and 60, is that this is across 20 hours here, so we're going to double up the 16 that's there to get 32. And that will give our total, and I'll do that on my calculator. 28 plus 24 plus 36 plus 32 is 120 students. Question 17. Show that the equation x to the 4 minus x squared minus 5 can be written in the form x equals the fourth root of x squared plus 5. All we need to do here is get x to the 4 on its own, so x to the 4 minus x squared minus 5 equals 0. Therefore, x to the 4 equals x squared plus 5 by adding x squared and 5 to the other side. Therefore, x equals the fourth root of x squared plus 5. Part B. Starting with x0 equals 1.5, use the iteration formula 3 times to find an estimate for the solution. So, x0 equals 1.5. Therefore, x1 is going to be the fourth root of x0 squared, so 1.5 squared, plus 5. On my calculator, I'm going to do 1.5 squared plus 5. So we want the fourth root of 7.25. And we're going to do that on the calculator. It's going to give us 1.6409, etc. And we want this to be done 3 times. So x to the 2 is going to be the fourth root of 1.6409 squared plus 5. So I'll leave this on my calculator and I'll square it. Plus 5. And then I will do the fourth root of that. And that gives me 1.665398, etc. And then we'll do it one more time. And once again, I will square this on my calculator and then add 5 and then do the fourth root of that. And I get 1.66976, etc., etc. And as an estimate, which is all they want, we're just going to write down 1.669763088, which is everything I can see on my calculator. Question 18. 2a compared to 5c is 6 over 25. 4b compared to 7c is 20 over 21. Show that a plus b compared to b plus c is equal to 17 compared to 20. So if we look at the first one first, 2a compared to 5c equals 6 compared to 25. Therefore, a is just going to be 3 here, and c is going to be 5. And on the one on the right, we have 4b compared to 7c equals 20 over 21. So in the same way, we're going to say b equals 5 here, and c equals 3. So now we need to make sure that the c's get to the same number. So we want them both to be 15 here, because 5 times 3 is 15. So in order to do that, we're going to times both on this side by 3. So we're going to have the ratio of a to c is 9 to 15. And on the right, we're going to need to multiply both by 5. So the ratio of b to c is going to be 25 to 15. Therefore, the ratio of A to B to C, as C is now 15 in both, we can say is 9 to 25 to 15. Therefore, A plus B in this scenario compared to B plus C is just going to be 9 plus 25, so 34, compared to 40, which is 15 plus 25. And that will just be 17 over 20 simplified down, as required in the question. Question number 19. ABC is a right-angled triangle. AB equals 9.3 centimeters, to correct to the nearest millimeter. AC equals 12.6 centimeters, correct to the nearest millimeter. Calculate the lower bound for the size of the angle marked X. You must show all of your working. So 9.25, opposite angle, 9.35, making sure not to include the 9.35, and similarly over here, 12.55, hypotenuse, 12.65. Again, do not include the 12.65. So we have here the opposite angle and the hypotenuse angle, the opposite side length and the hypotenuse side length. Therefore, we're going to use sine. So sine of x is going to be equal to the opposite over the hypotenuse. And we want the lower bound here. So we want to make this as small as possible. Therefore, we want the smallest opposite on the top and the biggest hypotenuse on the bottom. So we're going to say smallest opposite over biggest hypotenuse, as that will give the smallest number. So that's going to be 9.25 divided by 12.65. Therefore, if we do sine to the minus 1 of this to get x, we're going to get 9.25 over 12.65, and we can just pop that in our calculator, which I'll do just now. Sine to the minus 1 of 9.25 divided by 12.65, and we just get x equals 46.989, or 47 degrees. Round it up. Question 20. ORT is a triangle. OT equals A and RT equals B. M is the point on OR such that OM compared to MR is 2/3. Express MT in terms of A and B. Give your answer in its simplest form. So because we have this, we know that 2/5 and 3/5 is the actual side length of OR. So we can say that OM is 2/5 of OR and MR is 3/5 of OR. And OR is just going to be, we'll go along A and when we go minus B. So OR is A minus B. Therefore, MR is going to be 3/5 of A minus B. Therefore, MT is going to be, just going to scroll down slightly, 3/5 of A minus B plus B, because we're going from M to R and then to T, which is 3/5 A minus 3/5 B plus B, which is 3/5 A plus 2/5 B, which I would say is the simplest form, 3/5 A plus 2/5 B. Moving on, question 21. Here is the graph of y equals fx. On the grid below, draw the graph of y equals fx minus 4. All we have to do here is move the shape down 4 squares, because we're just adjusting the y. So at the moment, it goes from 0, 0, up 1 to the left, and then 1 and then across. So we're going to start here, and we're going to go up 1 to the left, 1 and then across. And is there a base to it? There's no base to it. On the grid below, draw the graph of y equals f to the minus x. We will just be then flipping that in the y-axis. So nice and easy, just draw it just like this. Lovely. And that's question 21. So question 22. There are only blue pens and red pens in a box. The number of blue pens is 4 times the number of red pens. Rita takes at random 1 pen from the box. She records the colour of the pen and then replaces it. Rita does this n times where n is greater than or equal to 2. Write down an expression in terms of n for the probability that Rita gets a blue pen at least once and a red pen at least once. So we're told the number of blue pens is 4 times the number of red pens. So red compared to blue is a ratio of 1 to 4. Therefore 1/5 red and 4/5 blue. We want the probability that Rita gets a blue pen at least once and a probability that she gets a red pen at least once. So probability of only reds is going to be 1/5 to the power n. And similarly, probability of only blue is going to be 4/5 to the power n. Therefore, probability of not only red and not only blue is going to be 1 minus the other 2 possibilities. As if you're never getting blue and you're never getting red, everything you're left with, you have to have got red and blue at least once. Question 23. Here are 3 similar triangles, ABG, ACF, and ADE. ABCD and AGFE are straight lines. Show that, AB compared to BC compared to CD has a ratio of 1 to 2 to 3. Show that the area of ABG compared to the area of BCFG compared to the area of CDEF is 1 compared to the 8 compared to 27. So, we want the areas here. We are told that AB is 1, BC is 2, and CD is 3. So as these are similar triangles, we know that the area of ABG being 1 means the area of ACF is going to be 9, as a full length of this is 3. Therefore, the area of ADE is going to be 36, because the full length of that is 6. But the question's saying the area of ABG compared to the area of BCFG compared to the area of CDEF. So they are the quadrilaterals. So area of BCFG is going to be 9 minus the original triangle at the top. Because all we want is this section here. So that's just 8. And similarly, area of CDEF, which is just this here, is going to be your 36 minus ACF, which is 9, which is 27. Therefore, we know the area of ABG is 1, area of BCFG is 8, and the area of CDEF is 27. Therefore, the ratios work as expected. Question 24. The diagram shows 8 identical regular octagons joined to an enclosed shaded shape. Each octagon has sides of length A. Find in terms of A an expression for the area of the shaded shape. Give your answer in the form P lots of 2 plus square root of 2 A squared, where P is an integer. You must show all your working. So this is the final question on the paper. So how we're going to do this is we're going to change this into a square with 4 small triangles around the outside. Now, we know that each side length in the octagon is length A, so I'm just going to write A onto some of these triangles here. And A and A. So what I basically need to do here is work out the length of this side here. So let's call it X. What I've essentially done here is I've drawn a right angled triangle because it's a right angle between the 2 regular octagons. Therefore, X squared, being the hypotenuse of the triangle, equals A squared plus A squared. So X is going to be the square root of 2A squared, which is the same as root 2A. So that means, need my pen again, that means the length of the square is going to be, we know this here is A because it's the length of the octagon, and this is going to be A plus root 2A plus A, which is 2A plus root 2A, which is the same as A lots of 2 plus root 2. So, if I scroll down again, therefore, the area of square equals A lots of 2 plus root 2 squared, which is going to be the same as A squared lots of 2 plus root 2 squared, which is going to be A squared lots of 4 plus 2 root 2 twice, so 4 root 2, plus root 2 squared, which is 2, not 4, is going to be A squared lots of 6 plus 4 root 2. So now we need to find the area of the small triangles around the outside because we want the full shaded shape. And this is nice and easy because we already know all the side lengths. So what we're going to do here, I'm just going to scroll up so you can see the triangle, is A multiplied by A divided by 2, A squared over 2. Therefore, the area of 4 small triangles, as there is 4 around the outside of our square, is 4A squared over 2, which is 2A squared. And therefore, finally, the area of the shaded shape is going to be A squared lots of 6 plus 4 root 2 plus 2A squared. And the question wants us to give this in the form of P lots of 2 plus root 2 A squared. So we'll take the A squared out of the whole thing, and we'll say 6 plus 4 root 2 plus 2, which is the same as A squared lots of 8 plus 4 root 2. And so we can take a 4 outside as they want it, open brackets, 2 plus root 2 lots of A squared, which is the format they want it. And that is our answer and the final question on the paper. Hopefully this walkthrough was helpful for you. If you've got any questions, leave them down below, and hopefully see you next time. Thanks for watching.